I would like to call Mr. D.R. Pathak to deliver his presentation.
Thank you, Chair. I think I've given to, as per program, I has given to the 15 minutes, but he reduced the 10 minutes. I'll try to do in the 10 minutes. Yeah, okay, my name is Dundiraj Pathak. I do research in university teaching by passion, but I'm mostly involved in consulting sector in the field of geotechnical, geoenvironmental engineering, and integrated waste management. I work in Southeast Asia and Africa, and currently I'm working in Asian Development Bank as a waste management specialist in Kathmandu. And today I'm coming here in the capacity of the president of Center of Research for Environment, Energy and Water. This is one of the partner organizations of this first Hydrogeological Congress. Fortunately, I'm also a member of this NHA. Today, my topic is, I'm not going to present all data and other things, just how this extreme knowledge, from all the experts' knowledge can convert to this open dump to at least the engineering landfill site to protect our groundwater and surface water and other things. I'm not talking about, in earlier presentation, you heard the extraction of the phosphorus, nitrogen, and potassium from the fecal sludge or from the solid waste. But at least we're talking here about you can convert this biodegradable or fecal sludge into at least fertilizers before jumping to this extraction of the phosphorus and other things. Okay. This is the background. You see, we have a 293 municipality, and we generate almost more than 5,000 tons municipal solid waste. Out of 5,000, almost 60% is the organics, which degrade, which is the one of the licit generating waste. And in Nepal, almost 50% of the total waste generated is not, collected. If collected, they go to the open dump without the proper disposal or the proper treatment. You can see the current situation. We burn the waste at the bank of the river, nearby the rivers, and we dump the waste not in the city area. You see, this is the bottom right side photograph is the Gosai Kunda. We have started to dump our waste, and we are degrading our water, surface and groundwater from the in the mountain, not in the city area. Then we started our degraded water. That's at least we have to convert these open dump practices to at least to the engineer landfill with the knowledge of you people like hydrogeologists, geotechnical or engineering geologists. Yeah. This is another case, like even the fecal sludge. We declare the ODF. We ask to the people to construct the septic tank. But this is the real situation of our septic tank. We use just the ring, and we just change our diffuse pollution sources to the point pollution sources. And the septic tank is one of the major groundwater polluters in these days, because these types of the open septic tank we prepare, there is no seal, and ultimately go to the converted to infiltrate to all these contaminants to the groundwater system. I'm talking about how to convert this dump site to the engineer landfill site. But if you constructed the engineer landfill site, how we make this engineer landfill site to the finally the dump site? This is one of the example of the Sistole landfill site. In 2005, we constructed as a sanitary landfill site. But finally now, and after the 20 years, almost 15 years, we converted one of the vulnerable dump site, which is all the major sources for the contamination in surface and groundwater as well. And this is also another, our situation, because the disposal practice is not only related to the design, not related to the quality construction, but related to the operational practices also. Okay, this is how this, our Sistole is converted to the sanitary landfill to the dump site example. You can see from 2003 to the 2022 photographs. And finally, we converted this almost 8 hectares land to the open dump site right now. And you can see here area. Initially, it was designed for just 2.5 years, nearly 3 years, to accommodate the around 150,000 tons waste. But finally, we disposed there more than 3 million 3 million ton waste over the last 15 years, and just this good sanitary landfill site is converted to the dump site and became one of the major groundwater polluter. Yeah, all of you know how this disposal site, the contaminants reach to the groundwater system without any proper barrier system, without good liners. If you have no any liner system, ultimately go to the leachate to the groundwater, or you either go to the surface water. Therefore, I'm talking about how this open dumping practice can improve technically as well as in policy and some standards, enforcing some standards. The first thing, the open dump to the engineered landfill is not like a revolution. It takes time. This is the gradual process. But at the same time, you have to think not only in like design, not only in the operation, you have to think about from site selection. Right now, in most of our disposal site is located in the river bank. That's in the floodplains and other things. That's first of all, we have to think about where is the better site for the construction of these landfill site. That's why we have to start from the site selection. Then we have to proper design, proper construction, and then finally the operation should be as per our guidelines, what we have prepared for the sanitary landfill site operation. And at the same time, when we improve in technically, at the same time you have increasing the environmental standards as well as regulatory monitoring and like enforcement framework also. When you work together in the both sides, then we can convert this dump site to the engineered landfill site. I'm not going to talk about the detail how to do in this project, how to identify the site properly based on the different parameters. It's not only hydrogeological, not only geotechnical, or not only like an accessibility. All are the social and environmental consideration. I have to think about the site selection of the landfill site. And after the site selection, we have a lot of rigorous assessment will have to be done. And finally, the consultation with the public. This is completely lack in our context because normally we people, our expert or government side want to hide with the public. When you go to the daytime, the municipal authority says, so we have to go in the evening to see the landfill site area or something like people come there and they obstruct, that's why that types of the, transparency doesn't work for the proper operation. That's why this consultation with the people is very important for the site selection as well as and the design of this also engineered landfill site. This is the site, how to choose the different types of depending upon the type of the land. The major things we have to consider to the design of the engineered landfill site, the first thing is how to develop this barrier system, proper containment system. That should be a good liners. That should be a good leachate collection system and gas management system. And of course, that should be a groundwater protection work as well as surface water control and subsurface migration of the landfill gas. The methane is one of the major gases we generate in the landfill site. Of course, the monitoring of the groundwater and leachate. Because we should have some groundwater monitoring wall in both in upstream and downstream side. And most of these, the monitoring wall are missing in our sanitary landfill site what we have developed. And site closure, post-closure plan is also very important. After 10 years or 15 years, even 20 years, the gas is being generated. Even the leachate is continuously generated, and you have to continuously monitor this groundwater well and as well as other leachate sources. And the major missing part here is that sanitary landfill, engineered landfill, whatever you say, everyone say like dumping site. So when you say the dumping site, you don't need any hydrogeological assessment, you don't need any geological assessment, you don't need any geotechnical assessment, and you don't design any liner or barrier system. And finally, all these leachate go to the groundwater system. And we are talking about our groundwater is not, fit for the drinking. This morning, our minister says the shallow groundwater is not fit for the drinking. This is the reason. But we are not talking about these things. Yeah, this is the proper, the engineered landfill site, at least how to design this the barrier system like clay liners, geomembrane. They are a combination of the different, because we have a lot of technology in these days. You don't worry about the technology, but we are worried about how to integrate these things in our engineering. It's a very important things. And how to operate these things properly is another important things. What we are missing right now. This is the existing landfill site we have already developed in the municipality of Nepal. This is like one of the examples of Nepal guns. But we have a very proper barrier system, very good leachate collection system. Now finally, if you have not a good operation practices, this again is converted to the dump site, and many cases already happen in our municipality. This is the pity part. Yeah, this is one example. Recently, Bansari Dara, everyone knows this name in this day for any field of the people. This is the Bansari Dara. We have designed properly. We have a very good like clay liners, geomembrane, and everything is there. Very good drainage system. But you see, now finally when you start to operate, you don't follow these operational guidelines as per the engineering landfills or guidelines, then it's finally converted to the dump site. Again, another problem is happening there. The all leachate is going to the river system or ultimately in groundwater system. I'm talking about this monitoring and utilization land. Of course, these are very important things. We have to think, when you're talking about the sanitary landfill side, you have to think about the post-closure plan also before 20 years back. How to utilize this land, how to monitor the continuously this gas and other water quality parameter after the post-closure. Then these things are very important. I'm not going to detail about this. And finally, I want to say something here. The first thing, we have to, this gradually see this our open dumping practice. Almost 90% of our municipality dump the waste. And we have to convert this dump site to the gradually from control to the engineer landfill and ideally the sanitary landfill. As an engineer, I would say the engineer landfill at least. But not only site selection, not only design, we develop is not only important things. The another things you have to think about the operational practice also. My today's talk is focus on how to dump site convert it to the engineer landfill because of this, the combination of the knowledge of hydrogeologists, geotech, and all the soil scientists, environmentalists. But we started to do it, but finally we failed again because of the poor operational practices. The good sanitary landfill ultimately converted to the open dump. That's why we have to work in vice versa. We have to talk about the, but as a waste management students, landfill is not only a solution. I have to say, because this is the hydrogeological forum and all are the geoscientists, then I'm focusing only in this topic about how to convert. This is the last resort of the, the waste. That's why we have to start from this point. But landfill is the only venue where at least not more than 30% waste have to be, disposed there. 70% or more than 70% have to be recovered and treated as resources or raw materials. We can be done this is, we have a lot of technology. Having said that, I'm not going to, because I've already over the time, yeah? That's why I'm not reading all this conclusion. This is the bottom line, what I already mentioned. Having said that, we have to stop degrading our water from mountain to the Tarai. Even in the Everest, Mount Everest, you have already read the news. There are the microplastic in the ice core because we have started, because this is almost 4,000 meter altitude. We have like the waste there. If we don't have a good collection and transportation system, ultimately this degrade there or spread there and finally go to the either our water system and other, if you burn, go to the your system. Then all that, one of the major polluters. Then we started the pollution from Everest to the city area. That's why the waste doesn't mean that the only is related to the urbanization, is not only related to the urban centers. It's all about, like in these days we are talking about the marine pollution and marine plastic. Even where the landlocked country, so many experts are working in marine plastic pollution, working on the marine plastic pollution, but we are not talking about the mountain plastic. Our mountain, our Everest are full of the plastic. Has already become like dump site. That we have to think about the mountain plastic. We have to think about this proper waste disposal. Then this is our duty of these like geoscientists or whatever is like hydrogeologists or geologists or engineering geologists, geotechnical, whatever your terminology you can use. All the this knowledge can be combined to shift this dump practice to the at least engineer landfill side. Thank you very much. Thank you.
Any question? दुईटा प्रश्न मात्रै लिनु होला, समयको अभाव छ.
Namaste and good afternoon. It's me, Samanda Kanel from NAS, geotechnical engineer. I just have a query, not a question actually. Our team have done some research regarding the contaminations and change in engineering, geotechnical engineering properties of a soil in a systole. We found that the value of a K, coefficient of permeability, was reducing. And during our literature review, we found from very different literature that the K might changes. It suggests that K might increase or sometimes might decrease. So percolations may happen, or it may cause in the flash floods if there is no percolations of water during the rainy seasons. So this is just a query that what might be the reasons for that variations of a K. It might be sometimes increasing and sometimes decreasing due to the leachate of the landfills you talk about.
Yeah, I think in my knowledge, I think the clay is also one of the complex materials. Then a lot of minerals there, and you're talking about sometimes the K values decrease or sometimes increase. It depends on how many times you conducted, how long you research you done. Also one part, because based on one sample or few researches, we cannot go in conclusion. But the bottom line of use of the clay here in the landfill system as a barrier is as this liner. That's why the main purpose of the use of the clay here to increase the K value. Sorry, to impermeability. Because clay have impermeable natures. And in the past, we don't have a height or the technology or the materials like geomembrane and other things. And at that times, at per site specific situation, at least the clay have the less permeability value, and we can use as a barrier system. But in these days, we can use other materials. There are so combination of the different materials. We have the very impermeable in the natures to replace in the clay. I think this also was solution is such a level of confusion. But I'm not sure the leachate, because of the leachate, the K value sometimes decrease or increase. In my knowledge, I'm not sure about to say it happens. But of course, the clay is used here to decrease this K value. This is the bottom line of this, this liner system.
Anybody else? One more question. Okay. Yes.
Thank you, Dr. Pathak, for your nice presentation. I am Subodh Dakal from Department of Geology, Tirijana campus. Just a query, because I'm not much aware about this. So do you have something like integrated monitoring system for engineer landfill site or whatever landfill site currently in Nepal, so that we understand that what is happening, and then we use those knowledge for the future landfill site investigations?
Yeah, thank you, sir. But at least I already mentioned about some regarding the monitoring system. At least we have established the groundwater monitoring well, not all the sensor-like devices to monitor like gases and other things. At least we have established the groundwater monitoring well at the offstream. At least the two. Fundamentally, you have to do this theoretically. Then in many cases we have done. For example, even like systole is converted to the dump site. Initially, when we designed and started to operate as a sanitary landfill, we have two groundwater monitoring well, one in the offstream and in the downstream. And we have a provision to measure the groundwater quality in every 6 months. or in at least 1 year, depending upon your resources, then you can identify the, whether our barrier systems work or not because of with the monitoring information from the monitoring well. At least we have installed this groundwater monitoring well. Except this, we don't have other devices to monitoring the other parameters. But you see, just it works for 6 months or 1 year. After then, you convert to the dump site, and nobody's care about whether the well or not. This is the problem.